So I've put a bit of low power functionality into the code. At the moment it's just displaying the time. Now I've changed the way that it operates as well, so that to see the time you have to press a button and then it updates eventually. It takes quite a few seconds to get there, but it does update and show the time. So it's now going to show the time that the unit has actually been on. There you go. So the update is pretty slow. I'm going to maybe look into that and see whether I can speed up the update time. But because of the low power mode that I'm running it in, which is shutdown mode, it means that when you come out of shutdown mode, you actually effectively do a reset of the processor and it starts from the beginning. So everything is run through once and then it goes back to shutdown. Now the reason I've done that is because of the power consumption of both the processor and the Epaper display. So in shutdown mode, I can get the total consumption of this circuit display and the processor down to 3 microamps, which gives me a very long battery life for various reasons. And the problem is that the moment you come up above something around about 10 microamps, you start eating into the battery life. Now this display takes a milliamp, an entire milliamp while it's operating, i.e. the update time. And the processor, you can slow the clock down, but then it takes so long to do anything, you end up with the processor being on for longer. So I've sort of got a halfway house of a few megahertz. It's running I think at 8 megahertz on this code, but I've been down to 4. You can probably go down to 2 or 1, which means I've managed to get the current consumption of the processor down to single-digit milliamps. Now that's good because the battery, the CR2032, can't really handle heavy loads. If we look at the data sheet here, I've got the Panasonic CR2032 data sheet, and you can see that the nominal voltage is 3 volts and the capacity is 225 milliamp hours. So I've been working on a figure of 90, which I think was the rechargeable 2R32 figure. So I will get a much higher or a much longer battery life if I do go for one of these. So you can see the continuous standard load is 0.2 milliamps, so 200 microamps. Now if you look down at this graph here, operating voltage versus load resistance, you can see that down the bottom you've got milliamps, which is a bit more convenient than kilo ohms. And you can see that at 2 milliamps the voltage has dropped down to about 2.5 volts. So at 10 milliamps or even 9 milliamps the voltage is going to just drop so much that you're going to run the risk of switching off the circuit because it can't operate below 2 volts. I think that 2.5 is about the limit. So if I can keep it down around about, well, single digit probably on this scale, single digit milliamps, then I can probably operate the thing, and it does operate, but I suppose it depends on the capacity as to how long that will continue. The other thing that's interesting is that as the load resistance goes up, your capacity goes down in milliampere hours. So up around single digit milliamps, your actual capacity has dropped at this point here. It's dropped down to just over 100 milliampere hours, whereas if you're at 30 microamps you're back up at the 225. So it's basically halved. So by operating at high currents you actually end up reducing the capacity of your battery, so it's a double whammy. So it really does help being at low power, which means if I can get this down to 3 microamps, then that will give me effectively unlimited battery life. The only thing that you need is occasionally to update the display by pressing the button, which is a bit like the old LED the old LED wristwatches, except it takes longer to update. Hopefully I can speed that up, maybe with partial updates of the display or maybe something else. So I don't know why it's updating twice there either. That seems to be a recent bugette. But anyway, what it means is, I think if you calculate around about 10 seconds at around about 9 milliamps, I think, for a single update, you can have around about 6,000 of those over the lifetime of the battery, and effectively the 3 microamps is 0, so you can disregard that. And that's quite a few times looking at the time on the watch, because I mean, a lot of times you just look at a clock, you don't look at your watch. So I think that'll sort of work. You'll get quite a long battery life, still be able to see what the time is if you really need to. And I mean, having it update every 5 or 10 minutes, or even once an hour, or even once a day, eats into the battery so much, because the current consumption of the display is so high, and the processor is quite high as well. It eats into the battery life so much that you end up with a battery life of just a few tens of days, versus, well, I think it was something like 9 years on 3 microamps. So, so effectively, shelf life of the battery. So that's what I'm looking at the moment. I have got, because it's now in shutdown mode, you can't program it. I do, if you hold the button down, it goes into a recovery mode, which enables you to program, there you go, enables you to program the device, because that's now in a tight loop, burning battery power. If you then hold down this button, you go into a setup mode. Although thinking about it, the setup mode could be the recovery mode, because that's in a tight loop as well. So eventually it'll flip, after it's done a tick in recovery mode, it will flip over to setup mode. So this has got a menu, and it lets you set up the time. That's the current time, and there's an exit which will take you back to the low power mode, and you can also change what the menu is. So you can add one to the month, and you can add one to the day and the hour and so on. If it's a bit slow, but if we go back round to yeah, so exit will take you back out eventually. It's so slow updating at the moment, I need to speed that up. And this is in a tight loop, this isn't using shutdown mode and going back through reset. So what I'm trying to do is have the thing update in the background, so that if you press a button, within 2 seconds it'll actually process that, and then only update the display when you need to. So if you go back to the display like that, we should be able to skip. Yeah, anyway, I need to find exit wherever it is. It's not working too well. But anyway, still work to do, but it looks like this push to display time, let's just reset it, this push to display time operation will mean that I can get a long battery life on it. It just remains to see how happy I am using something like that. So once I've got the code better than this, and I know that it'll actually work and the buttons are a bit more responsive, then I'll look at putting it in a case. I'm going to build another one though. I think I'll leave this one as the development machine, as it were, and build another PCB and then look at putting that in a case. So yeah, moving on.